Like I said, 9.5 is properties of logarithms. And so these properties will be used when we start solving these equations on Thursday night, okay? Now, these properties of logarithms are similar to the properties of the exponents. And if you remember, a logarithm basically is an exponent, so that's why they sort of mirror each other a little bit, okay? So, first property is called the product rule of logarithms. Okay, so this tells me if I got a log of a product, so log base A at m times n, I can rewrite this product as a sum of the logarithms. I would have a log A at m plus a log A of n. So a product of the log of a product can be rewritten as a sum of the logarithms of those products factors, okay? Now in a second, it'll do examples over each of these to get us more used to them. So I'm just going to give us all the rules first, and then we'll go through the examples. So next I have the power rule of logarithms. So this is what I would do when I have a logarithm with the base raised to an exponent. So if I got a log base A of m to the p, so basically we rewrite the um, logarithm. We bring this p down the front, and we're going to rewrite this as a product of the p times the log a of m. So we bring those exponents down and write this as the product between the p and then the log base a of the m. All right, so this one would mirror the product rule of exponents. This one would mirror the power rule of exponents. And then we got one for logarithms called the quotient rule of logarithms. So this is when you got a log of a quotient, which means division. So if I have a log base A, m over n, I can rewrite a quotient as a difference of logs. Log A m minus the log A of n. And you know how I remember these? If I was doing the product rule of exponents, if I had two variables being multiplied, I knew that I would add the exponents. If I had a variable with an exponent raised to an exponent, I would multiply the exponents. And then if we had variables that were being divided with exponents, well, we always subtracted the exponents. So it's sort of how I always remembered these properties, okay? Now, there's another one we've already looked at last week, but it's really useful in this section. And this was the log of a base to a power. So, y'all, this one says a log base A of a to the x. So I'm taking a log base a with that base raised to an exponent. Well, last week we learned that this, in the long run, equals x. So it's just always going to equal that exponent when that base of the logarithm matches the base raised to an exponent, okay? So we got to recall this property on these examples. So y'all, what I'm going to do, I'm going to start doing 2 examples from this, 2 examples, and then 2 examples, okay, of the logarithm properties. So the first one we'll look at wants us to express as a sum of logarithms. So express as a sum of logs. Well, the one that expresses things as a sum was your product rule. So they're going to give me a product, and I'm going to rewrite the product as a sum of logarithms. So y'all, for number one, I got a log base 7 of 7 times 12. Now, they don't want me to evaluate this. All they want me to do is rewrite this as a sum of logarithms. So we're going to distribute the log base 7 to each of the factors and rewrite it. So I got a log base 7 of 7. That's my first factor. Plus, distributing the log 7 through, I get a log base 7 of 12. And we don't have to go no further. They just wanted me to express it as a sum of logs. And y'all, we've done that. So we'll go to number 2 now. So number 2, now what they do, they alternate between doing logs and LNs, which is the natural log. So for this one, I got ln of d times f. Now remember, in MATLAB, this is a ln, not an in, okay? ln. But I'm going to do the same thing. I'm going to distribute my ln to each of these factors and rewrite this as a sum. So I'm going to have ln of d plus ln of f. All right, we've written them as a sum of logs, and we're done. So that was using the product rule. Now we're going to look at 2 examples using the power rule. So for the power rule, they're going to say express as a product. Because the only one that's expressing things as a product is this power rule, where you take the exponent and multiply by the log. So these will be on number 3 and 4. So y'all, number 3, they're giving me log base c of x to the 9th. All right, so the power rule says I bring the exponent down to the front and rewrite it as a product. So we're going to take the 9, bring it down to the front so that we get 9 times the log base c of x. All right, we've now written it as a product, and we move on to number 4. All right, so number 4, we're going to have to remember what we did last week on the radicals. So number 4, they're giving me an ln, but y'all, they're giving me a cube root of 10. So for this example, we need to convert that cube root into an exponent. So I'm going to bring down the ln. I'm going to bring out my 10 because that's the base. And I'm going to raise it to an exponent that represents this cube root. So y'all, if you remember, I gave y'all way to rewrite radicals as exponents. I said you take the base, which is the a, and you're going to rewrite it as a fractional exponent. Well, the actual exponent by the a goes on top, and then the root of the radical, the n, goes to the bottom. Now, the 10 doesn't have a number by it, so you got to remember that the 10 missing exponent is a 1 on that, okay? So that means the top number of the exponent will be a 1, and then the index of the radical becomes the bottom number. So we rewritten this 10 and took that cube root and wrote it as a 1/3. Now, what we got to do, bring that 1/3 down and write it as a product so that you get 1/3 times the ln of 10. Okay, so they're not bad. You just got to sort of follow what they want done up here, okay? All right, so my third property was the quotient rule of logarithms. So for these examples, they're going to say rewrite as a difference of logs. All right, the one that's rewriting as differences is the quotient rule. I'm going to take the log A of the top minus log A of the bottom. It's always the top minus the bottom on that, okay? So these started at number 5. So for 5, I got a log base B of C over 3. All right, so we take log base B of C, and then that's going to be minus log base B of my 3. So it's the top minus the bottom. Distribute the log to both of them and be done. Okay, so number 6 is a ln of V divided by T. So y'all, we're going to do the same thing, right? We're going to distribute the ln to the top and then minus ln of the bottom. So I get an ln of V minus ln of T. Now, later on, they'll start with this and we'll go backwards. But for right now, we're just learning those properties, okay? All right, so sums, products, and differences. All right, y'all, so.
Oh wait, can you stay on that page so I can write the last problem?
Yeah. So what they'll start doing, they're going to use all these little properties and they're going to expand our problems out a little bit wider now, okay? So they won't tell us which property to use. We got to know based on, are things being multiplied? Do we got exponents to deal with? Are they being divided, okay? All right, y'all ready for me? All right, y'all, so let me push this back up. All right, so these examples are going to say rewrite as sums or differences of logs. And y'all, these are starting at about number 7 here, okay? So for number 7, I got a log base D of x to the 4th, y to the 8th, and z. So y'all, here's the thing. Since these factors are all being multiplied, I know that I'm going to rewrite this using the product rule, which says that I rewrite a product as a sum of logarithms. So we're going to distribute log D to every factor here. So I'm going to get a log base D of x to the fourth plus my log base D of y to the eighth plus my log base D of z. Now, this is not what we would consider totally simplified yet because I've got exponents on two of my variables. So now that we've rewritten it as sums, we now got to bring the exponents down using the power rule. Okay? So we've rewritten it as sums, but y'all, if they got exponents, you've got to bring the exponents down to be in the most simplified form. So that this would give me a 4 times log d of x plus bringing the 8 down, that'll be 8 times the log base d of y. Now the z only has 1 by it, so that's not changing anything. So that one will stay a log base d of z. So exponents must be brought down using the power rule to be in most simplified form, okay? And y'all, that's what would be put into Math Lab. All right, so we're going to turn it up a little bit on number 8 here. On number 8, we're going to have a log base b, and I've got a fraction here. I've got a p squared q7 over m4 b8. So we're going to invoke the quotient rule here first. So the factors on top will be positive when we rewrite it. The factors on bottom will be subtracted when we rewrite it. And I will distribute the log base b to every factor. So there's 4 factors here. So watch this. I'll do the log base b of p squared plus the q's on top, so it's going to be positive. That'll be a log base b of q to the 7th. Now the other 2 factors are on bottom, so they're going to be subtracted using the quotient rule. So it'll be minus log base b of m to the 4th, and then minus log base b of b to the 8th. So y'all, let me tell you this. I know on 3 of these, I'm going to bring those exponents down. But one of these is going to mirror the 4th property I gave you while ago of a log of a base to an exponent to a power. So watch this. This first one, I'm going to bring the 2 down. The second one, I'm going to bring the 7 down. So I'm hitting it with the power rule. The third one, I'll bring the 4 down. But y'all right here, log base b of b to the 8th. What's that going to equal in the long run? And y'all, what I'm looking at on that one
An
is,
x,
well, look
so
here.
it's
Log
just
base
the
a of
exponent.
a to the x is going to equal the exponent, and you said that was
8.
8, I think. Yeah, that's it. So this will give me 2 log b of p plus bringing the 7 down, 7 log B of Q, minus bringing the 4 down, 4 log B of M, and then minus, remember this last one just became a 8. Now, what makes these problems look long and complicated is just because we don't have any like terms and we really can't combine anything. Okay? Um, but yeah, that's what you'll be putting in math lab, that whole thing. All right, so knowing how I did this, let's see what we're going to do to this number 9 here. My number 9 has a ln of 4 on top over 9 x to the 9th y. So y'all, let me show you. You got one factor on top. You got 3 factors on the bottom. I will distribute the ln to all the factors. And all 3 of these factors on the bottom will be subtracted like these 2 were up here. So tops are positive, bottoms are negative, okay? So here we go. ln of 4, that's positive, minus ln of 9, minus ln of x to the 9th, minus ln of y. So y'all, I got one more move. What do y'all want me to do?
Move all your exponents.
Oh, good job. And really, the only one I
Or
got to
one.
worry about is that x to the 9th. So the x to the 9th, we need to move the exponent down. Good job. Because that is one thing y'all got to do if they got exponents, okay? So we'll just rewrite it all. ln 4 minus ln of 9 minus, that's going to become a 9 times ln of x, and then minus our ln of y. So y'all, they're not real bad. You just got to follow those properties they gave us and rewrite stuff according to those properties, okay? All right, so we got 2 tricky ones coming up, and that's because of the radical stuff. So let's do number 10 here. A log of a square root a to the 7th b. So y'all, the first thing I'm going to do is get rid of that radical. So let me bring down my log. Since the radical is affecting everything, I'm going to put the a to the 7th b in parentheses. So what I need to figure out, what exponent can I write to represent a square root? So y'all remember the cube root I wrote a while ago was a 1/3.
Is it a 2?
Yeah, remember we said if there wasn't a number in that little notch, if there's not a number there, we automatically would be a 2 for a square root. Well, you were close, but the bottom number on that has to be a 2. Make that a 1/2 on that, okay? So square roots are 1/2, cube roots are 1/3, and so on. All right, now, your next step is to multiply the exponents in here by that 1/2. So for the A, 7 times 1/2 gives you 7/2. And for the B, now remember the B has a 1 by it since it don't show an exponent. That's automatically a 1. And 1 times 1/2 is 1/2. So all I've done so far was get rid of the radical and then distribute the exponents in using the power rule for exponents. All right, these things are being multiplied. So we'll rewrite this as a sum. We'll have log of a to the 7/2 plus a log of b to the 1/2. So are we done with that?
No.
All right, no. So what you doing?
You move the what is it, 7/2 log A plus 1/2 log B?
Perfect. Good
Okay.
job. That is perfect. So 7/2 log A plus 1/2 log B. That's it. But if you don't move them exponents down, MathLab will mark those wrong, okay? All right, y'all, one more going this way, and then we're going to start with these answers and go backwards and rewrite them as a single log in a second, okay? So here's the big one for this section. Log A, and then I've got a big radical with a fourth root of m20 n16 over a to the third b to the fifth. So I will say this. I'm going to start out doing exactly like I did here. I'm going to change the radical into an exponent, and then I'll distribute it to everything in here, and then I'll start to add and subtract them and do all that, okay? So this one's got a little more work for us. So the first step, let me rewrite this, and I'm going to put m20 n16 over my a cubed b to the fifth. I'm going to put them in a big set of parentheses. Now, what exponent would I rewrite this fourth root as? So we need to figure out our exponent here first. Once we figure that exponent out, we'll start going through and distributing it, okay? So a fourth root would be written as what exponent?
1/4.
1/4. Good job. Now, since all this stuff was under the radical here, all these are affected by that 1/4. So basically, we need to multiply all these numbers in here. The exponents all need to be multiplied by 1/4. So I'm going to bring down my log A. All right. On the M, 20 times 1/4 is like 20 divided by 4, which will give me an M to the fifth. On the N, 16 times 1/4 is like 16 divided by 4, which will give me a 4. Right, for my A, 3 times 1/4 would be like 3 divided by 4, which I can't do nothing with. So that's going to stay at A, 3 divided by 4. And they're all the same thing on the B. 5 times 1/4 is like 5 divided by 4. Can't do nothing to that. So that'll stay 5/4. Alrighty. Now, I'm going to distribute the log A to every one of the 4 factors. So I'll do a log A, m to the fifth. All right, so when I distribute a log A to the n to the fourth, will that be added or would that be subtracted?
Added.
Added because it's on top. Good job. So that'll be plus a log A of n to the fourth. All right, so next factor is A to the 3/4. Would y'all add or subtract that one?
Subtract.
Okay, because remember, that's on the bottom. So that'll be a log A of A to the 3/4 And then how about the b to the 5/4? Adding that one or subtracting?
Subtract it.
Okay, so that'd be minus a log a of b to the 5/4. So we're going to bring exponents down to the front. But y'all, one of these is going to be a little bit different than the other three. So for the first term, we're going to bring the 5 down for sure. The second term here, I'm going to bring the 4 down for sure. But y'all look at here. What does this term equal? I got a log base a of a to the 3/4.
It's just.
Oh, I think you was on it, but I didn't hear you.
Oh yeah, it's just the 3/4.
It's just a 3/4 because remember the base matches that base raised to an exponent. And then on the last one, we're going to bring the 5/4 down because these don't match. So our final answer here would be a 5 log a(m) plus this one gives me a 4 log a(n) minus, we said this one was 3/4, and then minus 5/4 log a of b. So these at this last stage, you really got to notice if these bases are matching the base of the raised to an exponent. Okay, so you always got to take care of those, and their simplified form would be the 3/4. All right, y'all. So that is starting with a single, with a single log and rewriting it as sums and differences. Okay. So I'll let y'all catch up on those. And then we're going to start with sums and differences and rewrite them as single logs. So we're going to go the other way now. Which means we're going to go in exactly reverse order as we were doing on these, okay? All right, so if we're going the other way, y'all, they're going to say express as a single logarithm. All right, so my number 12 has a log base t of 3 plus a log base t of 79. So if I'm going in reverse, let's think about this. These are being added. So going in reverse, the ones that are being added need to be written as a product. So we pulled out that log base t, and my product will be the 3 times 79. Now, MathLab wants me to go one more step and actually multiply that 3 times 79. So that'll give me a log base t. Let's see, 3 times 79 gave me 237. All right, so I'm now a single log. Okay, so that's what MathLab's wanting us to do. Hit them in reverse. So let's see what we do here. Log of 10,000 minus a log of 100. So think about this. The ones that were being subtracted started out as a quotient. So the positive factors on top the one being subtracted will be on the bottom. So let's pull out our log. So we'll have our 10,000 over our 100. So we can actually divide that. 10,000 divided by divided by 100 gives me a log of 100. So that's the first answer you put in. Now this one, MATLAB will say, hey, that's the right answer, but this one simplifies further. So let's see what y'all would put. Y'all, there's not a base right here. So what's the missing base? Do y'all remember what we put if there's not a number here? Well, not a 1, but add a 0 to that and you get a what? 10. Good job. So remember, if there's not a number here, it's a 10. So let me ask y'all this. What exponent would you raise 10 to equal 100? And y'all remember, the front of y'all's calculator will do a
Square.
log at 100. So I think y'all tried to say something, but I didn't hear it. So how many times you multiplying 10 times itself to get me a 100?
It's squared. So 2.
Yeah, so that'd be what, 2?
Yeah.
And that'd be our final answer. So put this answer in first, and then it wants you to even simplify it further to a 2, okay? All right, y'all 14. So let's up it now. Let's do this one. A 1/4 log C of x plus a 4 log C of y minus 3 log C of x. So 3 terms here. So the first move I'm going to do is what I made y'all do on the last move earlier. If my last move was doing the exponents and bringing them down to the front, well, these numbers in the front, I need to now move back up and put them as exponents. Okay? So that this becomes a log C of x to the 1/4. Plus, this one will become a log C of y to the 4th. And then minus, this one will become a log C of x to the 3rd. Okay. So I'm going to rewrite this as a quotient. So let's see what we do. I'm going to bring out my log base C. X to the 1/4 is going on top. The y to the 4th is going on top also because it's being added. And then that'll be over the x to the 3rd because this factor was being subtracted. So y'all, technically we would be done, but this one has x's on top, x's on bottom. When you got x's on top and on bottom, we got to simplify those using the exponent rule. And the exponent rule tells me that the larger exponent is in the bottom on this case because 3 is bigger than 1/4. So since the 3 is larger in the bottom, we will subtract 1/4 from 3, and that'll give me the exponent I need on the x's. So I'm going to bring out my log base C. So the y to the 4th will stay on top. And then, like I said, since the exponent is bigger on the bottom, what we got to figure out is what 3 minus 1/4 equals. So for that, you can actually punch that calculator and do that. So let's go. If you don't like adding and subtracting fractions, I'm going to go to my calculator. It'll do 3 minus 1/4. Now, Carlesia, make that into an actual fraction. So watch. So you're going to get 2.75, but hit math and enter twice, and we'll turn that into an actual fraction of 11/4. So for MATLAB, we'd have to actually put in our 11/4 so that I get an x, and that gives me 11/4. All right, so that was sort of tricky, but yeah, that's what MATLAB wants on that one. And we went further because you had x's on top and bottom. If I didn't have x's on top and bottom, I would have stopped, okay? All right, y'all. 15 is going to be similar to that, so let's see what we got. ln x to the fourth minus 3 ln cube root of x squared. So y'all, first thing I'm going to do is convert this radical here. So let me bring down that ln x to the fourth minus 3 times ln. So let me see, the base is the x. So this fractional exponent, since the x has a 2 by it, 2 will be the top number. And then the bottom number would be the index of the radical, which is a 3. All right, y'all. So my first move, since this 3 is down in front, we need to move this 3 back up. So bring down your ln of x to the fourth minus ln of x. So y'all, when this exponent comes back up, it's going to multiply by the exponent already there. So what we need to figure out is what is 3 times 2/3 going to give us. So y'all multiply this out and see what we get. So that'll give us a 2. So this will become an x squared. Now y'all realize all we've done was convert the radical out and move the 3 up. Now, since these are being subtracted, we're going to bring out that ln. The x4 goes on top. Since this was being subtracted, the x squared goes to the bottom. See, y'all look here. We got x's over x's like I did up here. So we're going to subtract our exponents. This time, the larger exponent's on top, which means my final answer will be x. Now, 4 minus 2 on the exponents will leave me an x squared. So see, although they start out doing logarithm stuff, you still have exponent rules you got to follow in here, okay? So anytime you got x's on top and x's on bottom, you always subtract the smaller exponent from the larger. So here we subtracted 2 from 4. Over here, the larger exponent was on bottom, so we subtracted the 1/4 from the 3, okay? If you subtract the smaller exponent from the larger exponent, you avoid negative exponents, okay? All right, y'all, there's 2 more in this section. So 16 and 17 will say, simplify the expression. So these are saying simplify the expression. All righty, so 16, I got ln x squared plus 16x plus 60 minus the ln of an x plus 10. All right, so I can't do nothing inside the parentheses. So I'm going to rewrite this. Since it's being subtracted, I'll rewrite this as a quotient. I'm going to have ln of x squared plus 16x plus 60 over, since this one's being subtracted, the x plus 10 goes to the bottom. So y'all, if you had transitional algebra, what we got to do is simplify this rational expression. So to simplify this, you got to factor. Now the bottom's not going to factor. The bottom's going to stay at x plus 10. But y'all, our top will factor into two parentheses. So you got an x squared, that's going to be an x and an x. The last number was positive, so both of your factors will be positive like the middle number. Now, y'all, check this out. Can y'all find me any factors of 60 that'll add to get me a 16? So what multiplies to get 60, but when you add them, you get 16? All right, Carlithia, what do you got? 6 and 10? That's perfect. 6 and 10. Y'all, it has to be a 10 on one of them if this is going to simplify, because the only way to cancel out an x plus 10 is with another x plus 10. So these factors would cancel, and the simplified form will be ln of x plus 6. Okay, y'all? Now you got to keep it in parentheses, because if we didn't keep it in parentheses, it would do a ln of x plus 6. So since both of these are affected by the ln, you got to keep this one in parentheses, okay? All right, y'all, let's see what 17 has. Let me bring that one down here. 17, basically the same thing, but they're using logs. So log of x squared plus 10x plus 21 minus a log of x squared minus 9. So can't do nothing inside the parentheses, so I'm going to rewrite it as a single log. On top will be the x squared plus 10x plus 21. On bottom will be this factor, which is the x squared minus 9. So y'all check this out. Since both of these have x squared terms, they're both quadratic, means these will both factor. So we will factor the top and we will factor the bottom. So let's play at the top. That's the x squared, so that's going to be x and x. The last number is positive, so both of my factors will be positive like the middle number. All right, y'all, so on top, I need factors of 21 that'll add to get me a 10. So factors of 21 that'll add to get me a 10.
7 and 3.
7 and 3. Which means this bottom, one of these either needs to be an x plus 7 down here, or one of them needs to be an x plus 3 if we're going to cancel this, okay? So the x squared will be an x and an x. The last number is negative, so one of these will be positive, one of these will be negative. Now, x squared minus 9 is perfect squares. Carlithia, good job. You would take the square root of 9, which would give you plus or minus 3. So we got a 3 here and a 3 here. So y'all's bottoms will be perfect squares. So that's either going to be x plus a number and x minus a number. And the number is whatever the square root of that number is, okay? But y'all look here. X plus 3's cancel out. So I end up with a log. Now, since you're ending up with a fraction here, we do not need parentheses. I'm going to have an x plus 7 on top and then an x minus 3 on the bottom. Okay, because when you got fractions, it's understood that the numerator and denominator are technically in fractions. So you do not need, the parentheses. It's understood they're in parentheses, so you technically don't need them, okay? But up here, the reason I needed them was because my fraction canceled out and I was only left with that one factor. So I had to keep that in parentheses, okay? All right, y'all, that is 9.5 college algebra. So now I wanted to do a little bit of the support to keep y'all honest with those exponent rules, okay? All right, y'all, so this would be 9.5 support. So it's going to go over these exponent rules that I'm about to write right here. So the exponent rules, you have a product rule that says x to the m times x to the n equals x to the m plus n. We got a power rule that says x to the m raised to the n equals x to the m times n. I have a quotient rule that says x to the m over x to the n equaled x to the m minus n. And then the last rule would be my negative exponent rule. So x to the negative a equals 1 over x to the a. So I basically flip it and make the exponents positive if they end up negative, okay? So that was what I was avoiding. If you subtract the smaller exponent from the larger, you can avoid negative exponents with those fractions, okay? All right, so that's the exponent rules. They sort of match the logarithm rules a little bit, okay? So let's try these examples. Now, these examples are going to say simplify and write with positive exponents. So if you end up with negative exponents, you got to do this kind of stuff, okay? And y'all, there's only 5 of these. So number 1, x to the 5th times x to the negative 8. So since I'm multiplying variables, I'm going to add the exponents. So y'all, what we got to do, what is 5 plus negative 8 equal?
-3.
Oh, so I get an x to the negative 3. But remember, it said write with positive exponents. So I got this situation now. Since my 3 is negative, I need to put this whole thing under a 1. And you're going to get 1 over x to the 3rd. All right, y'all, final answer on number 1. Let's see number 2 here. Number 2 is y to the negative 4th times y to the 9th times y to the 8th. So y'all, they're all being multiplied, so I'm going to add all 3 of these exponents. So here's the question. What is a negative 4 plus 9 plus 8 give us? So y'all add them 3. So currently, what is that, 13? Now look here. The 13 is a positive exponent. So I do not have to do none of this. So y13 would be our final answer. All right, y'all, number 3. They're giving me a 9x squared squared times a 2x to the fourth. All right, so this is going to hit us with the power rule first because I got exponents raised to exponents. Now the 9 does not have an exponent, so that'd be a 1. So you would distribute that 2 to both of those. So in the first parentheses, I have 9 squared. Well, 9 squared is 81. And then on the x, 2 times 2 would give me x to the fourth. Now over here, the same thing. The 2 and the x both don't have exponents. So we'd treat both of them like a 1. So you got 2 to the fourth. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that'll give me a 16. And on the x, 1 times 4 is 4. All right, y'all. So next step, 81. Since we're multiplying these, 81 times 16 is 1,296. Here's my question. On the x to the fourth times x to the eighth, what would that give us? X to the fourth times x to the fourth. Are you going to multiply those exponents or add them?
Don't you just add the exponents?
That's all we're going to do. Good job. Because we got this going on right here. So let's see, what would that be? 4 and 4 would be x to the 8th. And y'all, that's the final answer. So the numbers, you actually got to multiply these numbers out. And then on the variables, add your exponents, okay?
Where did you get the 81 and the 16?
Oh, because right here you had a 9 being squared. So 9 squared on that. So 9 squared equaled 81. And then I had 2 to the fourth power right there. Because remember, since these are in parentheses, that exponent affects everything. And then since these are in parentheses, this exponent affected everything. So here you had 2 to the fourth, and that gave me the 16, okay? All right, y'all, let's see what y'all do here. How about this? B to the seventh over B to the negative 2. So you got this quotient rule going on here. So my question is, what is 7 minus negative 2 equal? So that's what you got with the exponent. You got the top exponent minus the bottom. So 7 minus negative 2.
9.
Good job, because remember, if you subtract a negative, it becomes a positive, and that'd be like 7 plus 2, which is 9. So, y'all, that's just a B9. That exponent's positive, so that would be our final answer. So, y'all, these aren't bad. You're just following those exponent rules. But we wanted y'all to see the exponent rules to see how similar those logarithms were, okay? All right, so let's see what we got here. 4x to the 8th, y to the 6th, all being squared. So remember, the 4 don't have an exponent. We'll treat it like a 1. And you're going to distribute that exponent to all 3 of these. So y'all, the first question, what is 4 squared equal? Grace, I seen you pop up. Okay, you got a 16. Good job. X to the 8th squared. Are you going to add those or multiply?
You add them?
Well, look up here, y'all. Here's what we got. X to the 8th squared. So you got an exponent to an exponent. So y'all don't add those. You're going to multiply. So 8 times 2 would give me x to the 16th. Y'all remember, you're only going to add exponents if you say you got an x times the x, okay? So knowing that, what's going to be the exponent of the y? Are you going to add those or are you going to multiply? Carnith, what you got? 12. Good
Yeah,
job. Because
12.
6 times 2 would make that a 12. And y'all, that is your final answer. So now remember, up here when I had exponent to exponent, I multiplied. But here I had x's times x's, so we added them, okay? So make sure what you got going on over here to do the adding or the multiplying, okay? All right, y'all, guess what? That is your support. Just going over a few of these exponent rules, and they were to get you ready for my logarithm rules, okay? All right, y'all, questions on that?
Can I see the log rules 1 and 2?
My log rules?
Yes.
All righty, let me pull that page up real quick. All right, let me see. All right, so these were my properties of my logs. So remember, the products were written as a sum. This one pulled out the power rule where we pulled the p down and multiplied them. And then this quotient we rewritten as a difference of logs. So they were sort of similar to those exponent rules, but you got to remember that these logs are really finding exponents, okay? So y'all, what questions do y'all have? Um, One thing, let me cancel my recording real quick.